The theory of relativity usually surrounds two theories by Albert Einstein and other mathematicians: special relativity and general relativity. The concepts introduced by the theory include spacetime as a unified identity of space and time. Special relativity includes the following postulates: the laws of physics are identical in all inertial frames, and speed of light in vacuum is same for all observers regardless of motion of source of light. General relativity generalizes the special relativity and Newton's law of gravitation, providing a unified description of gravity as a geometric property of spacetime. This has amazing consequences such as the time dilation and length contraction, and this is what has made our time travel fantasy a physical reality. The theory of general relativity and how are they created. Even though it's impossible to study black holes up close, great scientific minds have given us the insight into the phenomenon. How are black holes created? The most common way is by dying stars. Stars with a mass greater than 20 times the mass of our sun may produce a black hole. The more massive the star's core is, the greater force gravity that compresses the matter, collapsing under its weight. When extremely massive stars collapse, it explodes as a supernova. Relativity is a theory that explains how time and space are linked with both points of a single four-dimensional space, which can be curved and gives into the influence of gravity. When an object moves through space-time continuum, it follows the curvature of space. Large objects warp spacetime and causes a depression or sagging on the sheet's surface. Spacetime is distorted by the presence of matter. Gravitating bodies bend the spacetime continuum. The event horizon is the spherical surface that marks the boundary of black holes and where space is folded in on itself. Outside the horizon is where the escape velocity is less than the speed of light. Inside the horizon is where there's no escape is possible, hence the escape velocity would have to be greater than the speed of light. Continuum. Once a massive star collapses, the natural end product is a black hole, and according to the theory of general relativity, the bigger the black hole is of a star, its ability to distort the local time and space continuum in relativity has led to the postulated existence of a dense object into which other objects could fall, but out of which no objects could escape, hence black hole.